Okay, the topic of this video is increasing, decreasing functions and the first derivative. So using the using derivative, we can find out, we're going to figure out on which part the function is increasing, on which part the function is decreasing. So here is the guideline. So it's if guideline number 1, if f prime of x is greater than 0 for all x's on open interval ab, then f is increasing, which means if derivative is positive, then the function is increasing on that interval on which the function was taken derivative. If, let me take this one. If the derivative of function is less than 0 on open interval, then that function is decreasing on the closed interval. If the derivative of the function is equal to 0 on the open interval, then function is constant on the same interval but closed one. Okay, so let's take example. Here we have f of x equal x cubed minus 3 over 2x squared. Well, let's use chain rule and get the first derivative. X cubed, I am applying, just to remind you, x to power n prime is equal n raza x to power n minus 1. So following that rule, f prime of x is equal 3x squared and minus 3x, because twice 3 over 2, it's going to be 3 and 3x. Now, what are going to be here critical the values, meaning at what value of x the function is going to become 0. To find out, I'm going to place 3x squared minus 3x is equal 0. 3x is a common factor. I'm taking out x minus 1 is equal 0. And x from here either 0 or 1. So 0 or 1, those are our critical numbers. So these critical numbers, breaking the line of number, hold on, let me do it straight. Breaking line of numbers in the following interval. If this is our 0, this is our 1, then we are getting 3 intervals where 1 is from negative infinity to 0, right? This one is going to be from 0 to 1 and from 1 to positive infinity. So let me write down this. X is greater than negative infinity and less than 0. This one, x is greater than 0, less than 1. And third interval, x is greater than 1 and less than infinity. Okay, so let's take, what's the purpose of it? We are going to find out if the function is on these intervals increasing or decreasing. So on interval between negative infinity and 0, well, let's take a testing value, for example, minus 1. If we take f of negative 1, I mean f prime of negative 1, it's going to be 3 and then plus 3, it's going to be 6. Which is greater than 0. So remember the rule, if f prime is greater than 0, then f is increasing, then function is increasing on the interval. So this is going to be increasing. Let me write down on interval between negative infinity and 0, the f of x is increasing. Next, on interval between 0 and 1, we can take the value 1 over 2. If we take value 1 over 2, then f prime of 1 over 2 is going to be equal, let me see, 1 over 2 squared is 1 over 4, so 3/4, and then minus 3 over 2, it's going to be negative 3/4, which is going to be, let me move this a little bit this way, yeah, which is going to be less than 0. Negative 3/4, which is going to be less than 0, which means, based on this rule, it's going to be decreasing, right? So we have here decreasing. Okay, and on interval between 1 and infinity, I'm going to take 2, testing value 2, and f prime of 2. If I plug to f prime, these 2 result is going to be positive 6, which is greater than 0. Yes. Let me make sure it has space. Greater than 0, which means it's increasing. So I prepared the graph up front, so it will look relatively nice and not to make you wait while I'm drawing the graph. So what do we have here? Our critical values are 0 and 1. So with dark blue colors, 0 and 1. Critical value, look here, you have at point 0, you have a relative maximum. At point 1, you have relative minimum. And with light blue colors, those are our testing points. So what do we see here? Till 0, the graph is increasing indeed. Yes? Increasing. Here, the small place between 0 and 1 is decreasing. And here, on this end, it's increasing. Okay? All right. So, next one, take another example. Y is equal x plus 9 over x. So let's take derivative first. 9 over x. I'm going to bring to common denominator here. It's going to be x squared plus 9. Derivative. So remember, we are going to take derivative of the quotient rule. So if I have u over v prime fraction, it's equal u prime v minus v prime u, and divided by v squared. Okay, so which means first we are taking derivative of x squared minus plus 9, right? It's going to be 2x from here. Derivative of 9 is 0. And times v. v is x, so times v. Next, minus, we're going to take a derivative of x, which is going to be 1. This x is going to be 1, and multiply by, you know what, let me write down in details just in case. So x squared plus 9 prime multiplied by x minus x prime times x squared plus 9. Okay, and divided by x squared. Okay, from here we are getting 2x times x minus x squared minus 9 over x squared, and we are getting y prime is equal to the x squared minus 9 over x squared, which is equal x plus 3, x minus 3 over x squared. Yes? Okay. This one also, let me move a little bit down so they are crowded. This square and this parenthesis. Okay. So what do we need to pay attention? That x is at the point x is equal 0, right? We have this continuity, that's domain x cannot be equal 0, right? Here, cannot be equal 0. And critical value is going to be, if I take x plus 3 times x minus 3 equals 0. So from here, x is plus minus 3. And those are critical numbers. So if I draw on the line, it's breaking down between negative 3, 0, and positive 3. So we are going to get 4 intervals from negative infinity to negative 3, between negative 3 and 0, 0 positive 3, and 3 and positive infinity. So let's write down here. It's gonna be x is less than negative 3 and greater than negative infinity. Here we have x is greater than negative 3, less than 0. Here we have x is greater than 0, less than 3. And here we have x is greater than 3 and less than infinity. Okay, so if we take value on this interval, negative infinity and negative 3, so if you take, let's say, negative 4, right? Let's see. If we take negative 4, this parenthesis is going to be negative, right? If you take negative 4, this parenthesis is also going to be negative. This is going to be positive. So result was going to be in numerator positive. Here is positive, yes? Which means y prime is going to be greater than 0, which means increasing. Now we need to take between negative 3 and 0. Well, let's take negative 2. Let me clean this. We go over again. Negative 2. If we take negative 2, this is going to be positive, right? If we take negative 2, this is going to be negative. Okay, I should take this color so we can see. Positive, negative, and this is going to be positive because negative number squared is positive. So it's a result, it's going to be negative, right? Which means y prime is going to be less than 0, and we have the graph is, the function is decreasing. Next, between 0 and 3. Well, let's take 1. If we take 1, this is going to be positive. This is going to be negative. This is going to be positive, and the result is negative. So y prime is going to be less than 0 and decreasing. And between 3 and positive infinity, okay, let's take 4. Clean this. So if we take 4, this is going to be positive. This is going to be positive. This is going to be positive. So answer is going to be positive, which means between free and infinity, yes, it's going to be increasing. So y prime going to be greater than 0 and increasing. Okay, so what do we have? The graph is increasing. The function is going to increase on interval negative infinity, negative 3, and on interval 3 and infinity. It's decreasing on interval negative 3 and 0, and decreasing on interval 0 and 3. And I have already prepared the graph, so I don't have to graph it again. So those are our critical points, negative 3 and positive 3, right? Because of this, our critical points, right? Okay. So it's on interval, we said negative infinity, negative 3, it's increasing. Here it is, it's increasing. From here to here, it's increasing. And then from negative 3 to 0 is decreasing, right? And then from 3 to infinity, it's increasing, right? And from 0 to positive 3 is decreasing. All right? This is going to be our graph. Okay, next we are going to use first derivative test, which is already, we are using actually, it's a first derivative test to identify again critical points. Okay, to identify critical points, let me see. I would like to, okay, I'll keep it like this. So first derivative test will help us to identify critical points. So actually this title I could put right on the top because I'm using first derivative test to identify where it's increasing, where it's decreasing, and where our critical points are. Okay, so 1 minute. Right here. Okay. There we go. Much better. So let's continue. So we are continuing our first derivative test to identify on which interval the graph is increasing, decreasing, and where we have critical points. So here, on the case of 1 over 2x minus sine x, we have limitation. We need to identify increase, decrease critical values on interval between 0 and 2 pi. Between 0 and 2 pi. So let's see. First of all, we have to take the derivative. F prime of x is equal 1/2 of x is going to be 1/2, right? Because derivative of x is 1, so we have only 1/2 left. And derivative of sine x is cosine x. Let me write down. Is cosine x. Okay, well, let's identify critical numbers. So critical numbers are going to be, if I assign first derivative 0, 1/2 minus cosine x is equal 0. From here, cosine x is equal 1/2. Well, let's identify which angle has cosine x 1/2. So looking at the unit circle, 1/2, as we know, this coordinate that you see in parentheses. So first coordinate is cosine x, which on the other graph it's represented as x, and sine x. Okay, just like we marked down, cosine x represented our x, sine x represented our y. So this axis is our cosine x, and this is our sine x. That's why first come cosine, second come sine, so x and y. So let's see which graph as a first coordinate has 1/2. Here it is. Has 1/2, which is pi over 3, right? Let me zoom it so you can see, which is pi over 3, 60 degrees. Okay, let me write down. So x is equal pi over 3. Pay attention, I can't put here plus 2 pi n because I have limitation here between 0 and 2 pi. So, but within 2 pi, which is 360 degrees, I can find one more point, right? So let's see what this point is gonna be. This point is gonna be, which one also has the first coordinate 1/2. Here it is, which is going to be 5 pi over 3. That is negative 60 degree. If this one is positive 60, this one is negative 60, right? This angle goes like this. And this is a negative 60, it's going to go like this. Or in this case, 300 degrees, that comes, let me take from here. It comes from 0 and all the way to here. So which means 300 degrees, position of 300 degrees is same as a position of negative 60 degrees. Yes? Okay, so we have pi over 3 and 5 pi over 3, which is 300 degrees. So we have practically 3 intervals. One is, considering limitation, 0 to pi. So minimum will start from 0. So x is going to be greater than 0, less than pi over 3, right? Then we're going to have between pi over 3 and 5 pi over 3. And lastly, we're going to have x is greater than 5 pi over 3 and less than 2 pi. So, test value, so between 0 and 60 degrees, I'm taking 45 degrees, which is pi over 4. Pi is 180. If you divide by 4, you get 45 degrees. So if I plug 45 degrees, so I'm plugging here 45 degrees. How much I'm going to get? Positive or negative? Cosine 45, so sine and cosine 45 degrees, it's the same thing, square root 2 over 2. Here it is, 45 degrees, square root 2 over 2. Let me clean this so you will have it clean. So here is cosine, the cosine 45 and sine 45. It's square root 2 over 2. Okay, so square root 2 over 2, it's 144 and something. So 1/2, when you do minus bigger number, you are going to get derivative less than. So f prime of pi over 4, it's going to be less than 0, which means here we have on this interval the graph is decreasing. In between 60 and 300 degrees, which is 5 pi over 3, well, I'm taking pi. So if we plug pi, cosine pi here, let me see. Here we have cosine pi, this is 180 degrees or pi, it's -1 as you can see, right? Okay, -1, so half minus -1 is going to be end up with plus, which means we will have here, excuse me, f prime from pi is greater than 0, which means we have increase. Okay, and lastly, between 5 pi over 3 and 2 pi, which is between 300 and 360. So let's take 7 pi over 4, which is 315 degrees. Here it is. Look, this point is 300, right? And this is 360. So in between, taking this point, 315 degrees, 7 pi over 4. Okay, let's do that. Seven pi over 4. So how much is cosine for 7 pi over 4? Is square root 2 over 2, right here. Square 2 over 2. Square 2 is 144. So if we plug there, 1/2 minus square root 2 over 2, it's going to get negative. So we're going to get f prime of 7 pi over 4. It's going to be less than 0, which means it's decreasing. Okay, let's look at the graph I prepared. So to save time, what do we have? We have our critical points, pi over 3, 0, pi over 3, 5 pi over 3. Now, since it's on open interval 0 and 2 pi, right? 0 and 2 pi, therefore, on the graph, we have it as an whole empty circle, because it's an open interval. It's not square brackets, so we consider as a closed interval and put solid points. So it's an open interval. That's why on the end we put empty circles. Now let's explore. This point is 7 over 3. This critical point, 5 pi over 3, which is 300. And what did we say here? Between 0 and pi over 3, graph is decreasing. Here we go. Right? Between pi over 3 and 5 pi over 3, which is this point, from here to here, it's increasing. There we go. And the last interval is decreasing. 5 pi over 3 and 2 pi is decreasing, which here. How do I know where I stop? You just plug 2 pi and you will see how much the answer gets, and you stop right there. Okay? All right. Moving to next question. So using first derivative test, we can identify where graph is increasing, where is decreasing, where is the critical values. And then we will explore also where is the relative maximum, relative minimum, and so on. Okay? All right. Moving to next question. So based on practically first at the derivative test, we can clearly see relative at the extrema, relative maximum, relative minimum. Okay, Fourth example, let's take care of it. X squared minus 4 to power 2/3. Let's take first derivative. X prime of x is equal. So it's a chain, right? First I'm going to take derivative of 2/3, which is going to be 2/3 of x squared minus 4. And then I'm getting into x squared minus 4 and taking derivative of each one of them. Derivative of x squared is going to be 2x. Oh, here I forgot. It's going to be negative 1/3, right? Because 2/3 minus 1. Remember? Derivative of x to power n is equal n x to power n minus 1. So which means if we do 2/3 minus 1, we get negative 1/3, right? Okay. So negative 1/3 at the derivative of x squared is going to be 2x. Here it is. And derivative of 4 is 0. So this is what we get. And the result is 4x over 3 times x squared minus 4 to power 1/3. Okay, so let's identify critical points. Critical points is going to be when I assign the entire derivative to 0. 3 times x squared minus 4 to power 1/3 is equal 0. From here, 4x is equal 0 and x is equal 0. It's a 1 critical point. And second one, 3 times x squared minus 4 to power 1/3 equals 0. And x squared minus 4 is equal 0. And from here, x is equal plus minus 2. So we have 3 critical points. Let's identify. So x is greater than negative infinity and less than negative 2. Second one, it's going to be greater than negative 2 and 0, right? Third one, it's going to be greater than 0, less than positive 2. And the fourth one, x is going to be greater than positive 2 and less than infinity, right? Negative 2, 0, positive 2, 1, 2, 3, and 4. Okay, so let's take some testing value. What is it going to be? Testing value, let's say I'm taking, here I will take negative 3. So if I take negative 3, then f prime of negative 3, let's see, is it going to be positive or negative? Here we are getting negative. This is at the square, it's always going to be positive, right? So result is going to be less than negative. Look, this is going to be positive. Total is going to be negative, right? Okay. So less than 0. Oops. Which is decreasing. Next one, between negative 2 and 0, let's take x is equal negative 1. So what's going to happen for negative 1? Let me plug. If I plug here negative 1, so this is going to be negative, right? So this one is going to be also negative because it's going to be 1, right? Any numbers between negative 2 and 0, it's going to be less than 4, which is going to end up with negative. Result is going to be positive. So f prime is going to be greater than 0, and in this part, it's increasing. Next, between 0 and 2, taking positive 1. If we take positive 1, what's going to happen? Numerator is going to be increasing, right, because it's positive. Here still going to be decreasing, which is going to be less than. F prime of 1, it's going to be less than 0, which is decreasing. And lastly, let's take number 3. Positive 3. Since still it's going to be increasing. Okay, let's see. If I take positive 3, it's going to be positive. Positive 3. Now, if I square, it's going to be greater than 4, right? So, therefore, it's going to be positive here also. Therefore, we are going to have greater than 0 and increasing. Okay, and there we go. Here we have the function, which is showing the result on the function. So between, let's see, negative infinity and negative 2. Here it is. We have here decreasing. And between the negative 2 and 0 is increasing. Right? This is y-intercept. When x is 0 and you plug 0, you get a cubic radical of 16. Between 0 and positive 2, graph is decreasing. 0 and positive 2 is decreasing indeed. And between 2 and infinity, graph is increasing this way. All right. Question number 5. I think it's the last question. So f of x is equal x to power 4 plus 1 over x squared. So right away, first condition is going to be x cannot be equal 0, which is also going to be considered as a critical value. Critical value, just to make clear, are the critical points are points where derivative doesn't exist, cannot be equal when it's not equal 0, cannot be equal 0. Okay, so f of x equal. So again, since I'm using quotient rule, so it's going to be x to 4. Well, let me rewrite first x squared plus x to negative 2, because it's easier to take a derivative in this format rather than quotient rule. I don't like using quotient rule, so I always avoid convert it into basic the sum of two terms. So this way it's easier. So f prime of x, it's going to be equal to x and minus 2x to power negative 3, right? Okay, so which is going to be equal to x minus 2 over x cubed, which is going to be equal x cubed. Here I will have 2x to 4 minus 2. And if I take 2 out, I will have, if I take 2 out, I will have x to 4 minus 1, which it's going to be x to 4 minus 1. It's going to be x squared plus 1 and x squared minus 1. And x squared minus 1, I'm breaking down x plus 1, x minus 1. Okay, over x cubed. Oops. X cubed. Okay, so critical point. What is going to be our critical point? First one is x is 0, and second one, x cannot be equal plus minus 1, right? Here, if we take it equal 0, it cannot be equal plus minus 1. All right, so let's go over interval. So we have negative infinity, negative 1, right? Negative infinity, negative, the negative 1, right? And then negative 1 and 0, and then 0 and positive 1, and then 1 and infinity. Oh, ugly x. There we go. So, test value, I'm taking -2. So if I take -2, what we are going to get? This is going to be positive, right? -2, it's going to be, because it's greater than 1, it's going to be negative. And -2, it's going to be negative. And here is going to be negative. So result is going to be positive divided by negative, which is going to be negative. So f prime of -2 is less than 0, which means decreasing. Now, x between -1 and 0, let's take -1/2. Okay? Let's take -1/2. So this is going to be plus always. I can leave it there plus. So -1/2, this is going to be plus because it's less than 1. And this is going to be minus. And this is going to be minus. So we are getting minus over minus, which is going to be positive. F prime of -1/2, it's going to be greater than 0, which means increasing. Between 0 and 1, let's take +1/2. Okay, obviously -1/2 increasing, +1/2 it's going to be decreasing, but let's check it to be sure. So what do we have? We said this one is always, first parenthesis, always going to be positive. Now this one also positive, and this is going to be negative, right? And this one also positive, so negative by positive is going to be negative. So f prime of 1/2, it's going to be less than 0, which means decreasing. And lastly, in interval between 1 and infinity, what we want to take? Okay, let's take 2. So this first parenthesis is positive, as we know. This is also positive. This is also positive. This is also positive. All around positive. How nice. At least something is positive in this life. No, I'm joking. Don't believe me. A lot of things are positive in this life. Over increasing. Yes? Okay. So here we built this one, so a critical point where it is increasing, where it is decreasing. Okay, if you are interested to see the graph, let me draw it. I forgot to prepare, but I can draw it right now. It is going to be the following way. This and this. Okay, so what do we have? Critical values -1 and critical value +1, right? At the critical value 0, there won't be any value because it's coming from the division by 0. So 0 is going to act as an asymptote, correct? All right. So if I plug a -1 here, let me clean this. So if I plug -1 or +1, y is going to be +2. So if this is 1, 2, 3, it's 1, 1, oops, that's not what I meant. 1, 2, 3, 4, 5, 6. This is going to be positive 2. This one and this one. So let me bring this down so we can draw. And okay, so the graph will look approximately like this. Okay, and this is going to be your -1 and +1. So this point is going to be your relative minimum. Okay, okie dokie. So in next video I will cover second derivative where we are going to explore concavity and then find the extrema of the function. Okay, thanks for watching. See you in next video. Bye for now.